when we expand this, x times x, x times 4, 3 times x, and then 3 times 4, in all of those examples in which we've done a binomial of this kind of form, it's a bit trickier when there's a number in front of x, but that's not our focus for today. That middle term, this one here, that middle term, comes from the addition of these two numbers, the two coefficients of the x term. And those two coefficients come from the expansion of these two parts. And so our focus today is about going backwards, starting with the expanded form and going back into the binomial, the two bracket form. And there is a special term that we use for these types of expressions in which we need to factorize. So the special term is called a trinomial. Why do you think it's called a trinomial? Yeah, there's 3 terms. So anytime you have a and, they all have a x squared something x and a constant at the end, pretty much. So they all have that same kind of format. Now, we can make this harder, not right now, where the coefficient of x squared is not 1. That makes it quite a bit harder. And so you'll see some of those in there, but not many in that little task that you just did. That includes, it could be negative as well. Our focus for the time being today and tomorrow is looking at trinomials in which that coefficient of x squared is in fact equal to 1. And that's called a monic trinomial. And it is linked to what we call a quadratic function. So we've just done a whole heap of work on linear functions. We're now going to move on to other functions after this topic, and that's going to link us to what we call a quadratic function. So it's non-linear, and because of that x squared term, that's what stops it from being linear, having the x squared term. So I think we're right with our expanding. We did really well. We've done really well with that. So let's look at going backwards, the whole factorising idea and the monic trinomial. And hopefully you've recognised, like I said, the fact that you've got these two numbers. The two numbers in the brackets have to multiply to give that 6. The two numbers have to add to give that 5 or plus 5. So you've got to be careful with positives and negatives here. Factorising by grouping, which we did just before the test, and we'll recap that very quickly tomorrow as well, is looking at or shows you how that in fact works. How that in fact, those two numbers, if we split them into 2 and then factorise by grouping, we will also get to where we want to go. So splitting them into 2 is really looking at, well, I want the sum of those two coefficients, the two coefficients of x. Well, in this case, that is what gives us these two values that we are trying to determine when we factorise a trinomial in this way. So really today's lesson is practicing these kind of monic trinomials, and it's pretty straightforward when they're both positive. It gets quite a bit trickier when you've got different signs involved. So with this first one here, the first thing you should recognise is it's a monic trinomial, which means I can then set up with my factorising two brackets, and now I'm looking for two numbers that will multiply to this and add to that. What are the two numbers? So multiply to 12 and add to 7. 3 and 4. Perfect. All right, I'm going to give you like 30 seconds to do A, B, C, and then we'll talk about D. So here, when we're factorising, think about how that eventuates from the expansion. All of these involve the same kind of setup. At the moment, we're learning a skill. This skill is very important when we do our quadratic function work. So you'll see how that is applied with quadratics once we get to those quadratic quadratic or parabolic relationships. In the meantime, it's that skill that's important, needing to go from the expanded form to factorised form. And with this one, we need two numbers, multiply to give 3, add to give 4. What are they? 1 and 3. Yeah, it doesn't matter which one you put where. Next one, two numbers that multiply to give 7 and add to give 6. What are they? I've stuffed that up, haven't I? Multiply to give 6, add to give 7. Let's try that again. And yes, it is 1 and 6, thank you. And then this one, two numbers that multiply to give 27 and add to give 12. What are they? 9 and 3, thank you. All right. The next one, what's trickier about this one? You've got to take 5x, don't you? But the same rule applies. You've still got this plus 6, and that has come from two constants being multiplied together. But with that take 5 in the middle makes it not quite so straightforward. So we're still looking for two numbers. We're still looking for two numbers that multiply to give 6. But they must add to give -5. Because of that subtraction in there. Subtraction just means add a negative. So they must add to give -5. What are the two numbers? Let me give you another hint. Think about this. If you've got two numbers that multiply to give a positive but add to give a negative, what can you tell me about the two numbers? They both must be negative. Yeah. So this one here is actually of the trickier ones, the easiest. There's 3 types of tricky ones. So they both must be negative. What must they be? 3 and 2, perfect. -3, -2. So that's how we would tackle that kind of one. So as soon as you see the situation where you've got two numbers that multiply to give a positive but add to a negative, they both must be negative. This is the next type of tricky one. Same deal. You've still got a trinomial, which means we're still looking for two numbers that multiply to give -1, but they've got to add to give -4. So that makes it harder because now you should know one's positive, one's negative. Because the only way you're going to get two numbers to multiply to give a negative is that you've got when you've got one of each. So now you need to determine not only the factors of 21, for example, 1 and 21, 3 and 7, but which one's the negative one? So it's got to be -7. How do I know it's got to be -7 and not the other way around? Yeah, because then it'd be +4 because -7 plus 3 would have given me a positive value here, not a negative. And so that is my next hint to you. If they're both positive, if they both multiply to a positive but add to the negative, the first hint was they both must be negative. My next hint is negative number both have to multiply to a negative, which means that you've got to have one of each. If they add to a negative, what can you tell me about one of the numbers or about the numbers? The bigger one has to be the -1. Yeah. So that's the next hint. Whereas this one, other way around, so I guess final hint links to the other one. The fact that they both multiply to negative means you've got to have one plus and one take. But this time they have to add to 4, which tells me the bigger one has to be the positive one. And we're just going to spend some time now practicing all of that. You guys should be pretty good at this. So what have we got? +6 and -2. Because you would all know your tables, etc. If you don't know your tables, this is where we're stuck. Now, those links, those hints that I gave you are all written here. That's why I didn't write them down. They're all written here. So whether you want to use them or just do it intuitively, it's up to you. But let's try a few more. So when we fully factorise these, we are looking for two numbers that multiply to give 12, add to give -7. Now, one strategy, if you just can't see the numbers, is to actually list the factors in pairs. So you multiple factors of 12, 1 paired up with 12. Then you've got 2 and 6, and then you've got 3 and 4. Now again, next strategy, think, okay, I know that both of the numbers have to be negative because they multiply to a positive but add to a negative. So that probably then gives it away if you weren't sure originally. So don't be scared to list the factors and then alternate positives and negatives, because if you've got the option where one has to be positive, one has to be negative. Like C, for example. Here you've got the scenario where the two numbers have to multiply to give negative 40, but they have to add to give negative 3. Now that might not be obvious to you by looking at it. So start thinking about your pairs of factors that match 40. 1, 40, 2, 20, 3 doesn't, 4, 10, 5 and 8. And now think, right, one of them has to be positive, one has to be negative. Then you can think, oh, well, if I've got to add to a negative, the bigger one is the one that has to be negative. If you can work that out, it makes it so much easier. So it's got to be this term that's negative. And then hopefully from there you can figure out that it's 5 and 8. Well, positive 5, negative 8. And while I'm here, this one, so two numbers multiply to give 100, add to give negative 20, so that's got to be negative 10 and negative 10, which we could then write as x minus 10 all to the power of 2. So you've seen those ones before. All right, now it gets a little bit trickier. Sometimes we might have to remove a common factor first. Anytime a trinomial has a negative, we always factorise out the negative. Anytime the coefficient of x is not 1, we always try and factor out a constant. That might not work, but it will for the ones we're going to do today. And the best thing you do is you just take the negative out. Factorise out negative 1. Do not even try and factorise that one. Just factorise out negative 1 and then go from there. This one haven't finished. Two numbers that multiply to give 8 and add to give 6. Sure, sorry. And then I'll just give you some time to finish off B. You've got an exercise that you can now work on from your textbook, and there is also this that you might like to work on. I wouldn't do hang on. No, that's a lie. I was going to say don't do number 1 because they all look both positive, but some of them aren't. But 2 and 3 look a bit trickier. All right, last one. Two numbers multiply to give negative 14, add to give negative 5. So we know that one of them's positive and one of them's negative. And what should it be? Plus 7 and negative 2. Very good. Sure. Now, just while I've got people's attention, is that as far as I can go, really? Just whilst I've got people's attention, in your little factorising thing, there was one in there that had a 2 take x, which factorises to a negative. So I just want to show you where that comes from. So just speaking very quickly about your investigation. So if I head back here into the important information, the very bottom sheet is where I've placed the investigation. Actually, Mrs. Pateman did that for me, to be honest. And if I open that up, you'll see it there. And it will okay, so that's it. Now let's talk through it. You're allowed to work in pairs if you like. You don't have to, but it is a good collaborative exercise and certainly would be worth your while. But like I said, you don't have to. Some people don't feel comfortable. But what I want to talk through with that investigation is basically the mathematical thinking process. So the mathematical thinking process is on the inside the middle, and you can see there are marks allocated to each of the stages. So we've got the clarifying the problem. So what is the question asking? What conditions are given? Well, there's a whole heap. You've got to just quickly simplify those. And also, are there any assumptions that you might need to make, etc. Then you've got choose the method. So the choose the methods is more about what you're going to do and how you're going to do it. The maths involved especially, that's the main focus, before you actually do it. So you might need to think about that. Then the next stage of the process is to actually do it. What is it? You've got to design a roster or do your roster design. Now you might need to go back and, with these, it's not necessarily a linear, I'm doing this, I'm doing that, I'm doing that. You might need to go back and forth a few times. You might have thought, oh, I forgot about this as you're trying to design your roster. Okay, I'm going to go back, just write what I had changed my mind about in the choose the method. That's part of the analysis and the verification anyway, any changes that you decided to make. How can you tell it kind of makes sense? And is there, you might have to explain, I found these stuff easy to place, I found these stuff more difficult because blah, 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 whatever it might be. And then you've got your communicate findings. So that is where you actually need to think about who is it that you're presenting the information to, not me necessarily. It is the owner of the Megatronics department and toy department, and then just think about very quickly a summary of what you've been asked to do, what you did, and what your final response is. So all of those steps to the mathematical thinking process, which we've practiced a couple of times now in class, are important and allocated marks. Obviously, the most marks are allocated to the actual design of the roster. All right. Are there any questions? I've got any questions about that. So you've got a whole heap of information. You've got a whole heap of data. These rates are current rates. So if you were going out to get a job, they're the current rates that you'd be working on depending on your employment level and depending on your age, there is a difference as well. Okay. And there's a rubric to give you a bit of an idea of how the marks are kind of allocated within each category of the process. Are we clear? Does that make sense?
Do we get any problems on drugs?
Yeah, good question. I'll need to speak to Mrs. Payton. Probably not. Probably not.